Welcome to Eureka Math. I'm Mr. Shankel. Today I'm going to help you with Module 2, Lesson 8. Let's get started. Well, we're working with the algorithm now of division by fractions, so we're practicing getting this technique, these steps down so that we can solve these problems efficiently. And now we're posed today with mixed numbers, so I'm dividing by a mixed number. I could do this individually with a mixed number, and I'm going to show you how difficult it is so that I know we talked about it in class, but I'm going to show you how tough this really is to get the right answer and show you why the best thing to do is to make an improper fraction. So here goes. The first thing I would do is I would take 2/5 and divide it by 3. So if I'm using a model, I could find fifths like this. Okay, and then I would shade 2 of them. So these 2 would be representing 2/5, and then I want to divide that into 3. So I would just divide across this way, and I know that now that I've taken the fraction 2/5 and I've divided into 3, then I would shade, let me get a new pen here, I would shade this, and so my answer would be the double shaded part, which is here, and that is 2 out of all the boxes. Well, I've got 5 times 3, so it's 15. So 2/5 divided by 3 is 2/15. And but then I'm not done. I have to still do some more. I have to do 2/5 divided by 1/10, because I'm not just dividing by 3, I'm dividing by 3 and 1/10. So now I'm doing the and 1/10, and I know from our algorithm that I can rewrite this 2/5 times the reciprocal, which is 20/5, and 20 divided by 5 is 4. So my answer is 4 plus the 2/5, so it's 4 and plus the 2/15. So the answer is 4 and 2/15. Wow, that's a mess. Let me clear everything. Let me take that back. Let me clear this stuff. Alright, so not fun to work with mixed numbers. So what I'm going to do is change the mixed number into an improper fraction. And it's just another algorithm that makes it pretty easy here. If we just do this reverse C method, I can do 3 times 10 and then add 1, because I have 3 groups of 10, and that's 30, plus 1 is 31. So this new problem becomes 2/5 divided by 31/10. But same thing, I can't divide by a fraction, so I'm going to rewrite this, and I'm going to multiply by the reciprocal. So I'm taking this fraction and flipping it. That's my reciprocal. And now I can get an answer here. So before I multiply, I'm going to simplify. I know that 5 goes into 5 once and 5 goes into 10 twice. So it's going to make things easier. And then my answer is 4/31. Wow, that's not the same at all as my division by a mixed number. So I did something wrong. Division by a mixed number is a problem. I wouldn't try it. Change your mixed number into an improper fraction and then follow the algorithm. The answer to this question is 4/31. Okay, let's try another one. And I'm going to take my own advice here, and I'm going to change 4 1/3 into an improper fraction. 4 times 3 plus 1. 4 times 3 is 12, plus 1 is 13. And I keep the denominator, so this 3 stays the same. And that's going to be divided by 4 sevenths. I can't do that, so I'm going to rewrite as 13 thirds times the reciprocal, 7 fourths. I can't reduce 13 thirds, I can't reduce 7 fourths, I can't reduce 13 and 4, and I can't reduce 7 and 3. So I just multiply straight across. 13 times 7, well, that's 91, and 3 times 4 is 12, and that's my answer. 91 twelfths. Okay, a couple more. Hopefully you're noticing by now that these are problem set questions. So same thing. I'm going to get rid of this mixed number because they're pain. 6 times 3 plus 1. 6 times 3 is 18 plus 1 is 19. The 6 stay the same, and I'm going to divide by 9/10. I cannot divide by a fraction right here, so I'm going to rewrite this so that it's 19/6 times the reciprocal. And now let's see, I'm going to simplify first. 6 divided by 2 is 3, and 10 divided by 2 is 5. So that gets me a little bit better, and that's about all I can do. So 19 times 5, well, that's 95. And 3 times 9 is 27. It's an improper fraction, but improper doesn't mean wrong. Improper just means that the numerator is bigger than the denominator, and who cares? It's a good answer. In fact, it's an answer that I can do other things with. You know, I can multiply, I can divide, I can add, subtract. A lot easier with this than with a mixed number. Okay? Last one today. This time my divisor needs fixing, so I'm going to multiply and then add. So this is 12 times 2 is 24, plus 7 is 31. Twelfths, that stays the same. And that's my divisor, and I'm going to divide 5/8. Okay, I can't do that because it's division by a fraction, so I'm going to rewrite it. 5/8 times the reciprocal. And then, again, 4 goes into 8 2 times, and 4 goes into 12 3 times. So my answer is 5 times 3, 15, over 31 times 2, 62, and that's my answer. Okay, that's the algorithm. That's changing a mixed number into an improper fraction using the algorithm so you can divide with fractions. Hope that helps. See you next time.